Hello, grade 10 students. Welcome to our first science class for the second quarter. I am teacher Maribel and I'm very glad to be with you today. In this session, we are going to talk about the different forms of electromagnetic waves. You have learned from your previous science lessons that wave is a temporary disturbance that transfers energy from one place to another. And there are two important ways on how energy is transported in the world around us. We have the mechanical waves and electromagnetic waves. What are the differences of the two? Remember from your previous lessons that waves in water and sound waves in air are the two examples of mechanical waves.
Furthermore, electromagnetic waves such as visible light differ from mechanical waves in that they do not require a medium to propagate.
We are going to discuss how our EM waves formed after the music break. Stay tuned!
Tayo na muli pa rin ang mundo ng siyensya, tumuklas ng kaalaman sa hayop at halaman, kalawakan, kalupaan, katubig at kalangitan. Di ka may iwan sa pag-aaral ng agham, mag-eksperimento ng mga bagay para sa bayan ay aagapay. Ikaw ang batang scientist, ikaw ang batang scientist, ang pag-asa ng bayan. Ikaw ang batang scientist, ikaw ang batang scientist, ang pag-asa ng bayan. Ang pag-asa ng bayan.
Welcome back! And now, let us discuss how our EM waves formed. Electromagnetic waves are formed when an electric field comes in contact with a magnetic field. Electricity and magnetism can be static, but changing magnetic field will induce electric field and vice versa. And these changing fields form electromagnetic waves. Always keep in mind that the electric field and magnetic field of an electromagnetic wave are perpendicular or at right angles to each other. Remember also that the electric field or magnetic field are also perpendicular to the direction of the electromagnetic wave energy. Always remember that electromagnetic waves or EM waves travel at a constant velocity of 3 times 10 raised to the power of 8 meters per second in a vacuum space. Electromagnetic waves are deflected, neither the electric field nor the magnetic field. However, they are capable of showing interference or diffraction. Electromagnetic waves are considered to be transverse waves. To understand further, here are some characteristics of waves that you need to remember.
First, we have the amplitude, which is the height of a wave and usually measured in meters. The greater the amplitude of a wave, the more energy it is carrying. We have the wavelength, Rest is the distance between two consecutive rests or trough, and usually measured in meters. Frequency, or the number of waves passing a point in a certain time. We normally use a time of 1 second, so this gives frequency the unit hertz, since 1 hertz is equal to 1 wave per second.
There are different types of electromagnetic waves. We have the radio waves, the microwaves, the infrared, visible light, ultraviolet, X-ray, and gamma rays.
And these EM waves are splitted into ranges of wavelength known as the electromagnetic spectrum.
Let us examine this electromagnetic chart, starting from radio waves to gamma rays. Compare the frequency and wavelength of EM waves. Did you notice that as you move from left to right of the EM spectrum, the wavelengths get smaller and the frequencies get higher? And thus, there is an inverse relationship between wavelength and frequency, which simply means as one goes up, the other goes down. Electromagnetic waves can be described in terms of a stream of massless particles called photons, each traveling in a wave-like pattern at the speed of light. Each photon contains certain amount of energy, and the different types of electromagnetic waves are defined by the amount of energy found in the photons. Observe that the energy goes up as the frequency increases. Thus, energy is directly proportional to the frequency. Let us take this as an example. Radio waves have photons with low energies. Microwave photons have a little more energy than radio waves. Infrared photons still have more. Likewise, in the order of the different colors of the visible light, they are arranged from lowest to highest frequency. Electromagnetic waves can be classified as ionizing or non-ionizing form of radiation. The non-ionizing radiation is a part of the electromagnetic spectrum where there is insufficient energy to cause ionization. While on the other hand, we have the ionizing radiation. This is a type of energy released by atoms that travel in the form of electromagnetic waves, which includes the gamma rays and X-rays. Ionizing EM waves are more dangerous to humans than non-ionizing waves. We will further discuss this in our next lesson. Always keep in mind that the electromagnetic spectrum is a continuum of all electromagnetic waves arranged according to frequency and wavelength. And to summarize what we have learned, electromagnetic waves or EM waves are waves that are created as a result of vibrations between an electric field and a magnetic field. Electromagnetic waves can be expressed in terms of energy, speed, wavelength, and frequency. Frequency is measured in cycles per second or hertz, while wavelengths are measured in terms of meters. EM waves travel with a constant speed of 3 times 10 raised to the 8th power in a vacuum. The larger the frequency of an EM wave, the smaller the wavelength, and vice versa. The frequency of an EM wave is directly proportional to energy. We also learned that the higher frequencies of electromagnetic radiation, consisting of X-rays and gamma rays, are types of ionizing radiation. Lower frequency radiation, consisting of ultraviolet, infrared, microwaves, and radio waves, are types of non-ionizing radiation. The electromagnetic spectrum includes from longest wavelength to shortest, radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. And that's all for this session, guys. I hope you enjoyed our discussion. See you in our next lesson. Once again, this is Teacher Maribel, serving you with much love.